Hello everyone, in the last video we have seen the intro part of the state variable method. In this lecture we will see what is the standard representation of the state variable method, how we represent it, and what is these terms are. So without wasting any time, let's begin. Standard representation of the state variable method. It will always be in the matrix form. So what it is? Here is the x dot n cross 1 a n cross n x n cross 1 e. These are the some terms. Here x dash and y dash always be in the same order. Like here is the order is n cross 1. So n cross n, n cross 1, and cancel n cross 1, this term in a n cross 1 order. Similarly n cross m, m cross 1, m cancel, this is the n cross 1 order. Similarly p cross 1 is here. So p cross n, n cross 1, the ultimate order is p cross 1. Here p cross m and m cross 1. Then ultimate order of this term, combined term is p cross 1, that is similar to the p cross 1. Order should be the same. This is the main point. Now we will see what is n, what is p, what is m. Here m is the number of input, n is the number of state variable, and p is the number of output. Now first term, what is x n cross 1? X is a state vector. State vector as we know that it is a collection of the variables. So it is a state vector. It is a collection of state variable, and as we have mentioned n is the number of state variable. And in state vector, whatever n that will be here, it will be the number of rows. If n is 2, then number of row is 2. So let's have an example. N equal to 1, then x 1 cross 1. If n equal to 2, 2 cross 1, x1, x2. Similarly x1, x2, x3. After that, here is a concept. Number of state variables means n. Whatever value of n you have, that will similar to the number of time constant of the system or order of the system. N or number of state variable also known as the number of initial condition. So whatever thing is asked to find out, you will have always remember these terms. Now, what is x dash n cross 1? This term happened n cross 1. This is a differential form of x. So x is a state variable method. X dash n cross 1 is differential vector state. Means it is a collection of differential state variable. Here n is the number of state variables. Similarly, we will put the value of n, 1, 2, 3, whatever it is. We will have a matrix like this. It will be all more clear when we cover these concepts with some examples. We will cover previously asked gate questions also and some basic questions related to it. Now what is A? A n cross n is a system matrix. N cross n, here is the number of row or number of column, both are equal, so it is always be a square matrix. Like we put n equal to 2, here A 2 cross 2, A1, A2, A21. These are some basic concept of how to write a matrix. Now next term is what is U? U m cross 1. U basically a input vector. Vector means it is a collection of some variables or inputs. So its order is m cross 1. It is an input vector and the collection of input. So here if we put the value of m3, we will get a matrix like this: u1, u2, u3. Here. Now rest the term is B. What is B? B is the input matrix. That u is the input variable, but now m is the input matrix. Its order completely depend upon the value of n and m. For a single input, as we know, m is defined as an input. So for single input system m equal to 1, let's have an example n equal to 3. So the matrix will be b3 cross 1, b1, b2, b3. It's a matrix we will get after putting these values. So here is a point to note. For single input system, if a system is a single input, then the B matrix is always a column matrix. So the next term is Y. P cross 1. This is an output vector. So it is a collection of output. Whatever output we will get from a system, that will be collected in Y. So here P, as we mentioned earlier, y is the output, so here P denotes number of outputs. For multiple outputs like P equal to 2, 3, 4, 5, whatever it is, we will get a matrix like this. Now the term is what is CP cross N. Here the value of matrix C completely depend upon P and N. P is the number of output and N is the number of state variables. So for single output, that means P equal to 1, we will get a matrix like this. C 1 cross N, and it's completely depend upon the question or us how much value we will put of N. If we put N equal to 2, then the matrix will be C 1 cross 2. Here 1 is the number of row, 2 is the number of columns. So if we put the value of N is 2, then we will get C1, C2, means we have a single row but 2 columns. Like when it is a single output system and we put N equal to 3, we will get a matrix like this. C matrix 1 cross 3 means C1, C2, C3. So if for a single input system or single output system, B matrix is always a column matrix and C matrix is always a row matrix. And the last term is D. It is a data transmission method whose order depend upon P and M. If state variable is 0, then we will directly talk about input and output. As we know that P is the output and M is the input. So here is the missing term is state variable. So when state variable is missing, we will directly talking about input and output. If input equal to output, then we will get a square matrix. So the order of this matrix is depend upon the number of input and number of output. Generally it is a seesaw system, so it's D equal to 1 cross 1. If this value becomes 0, then what will be the new equation will be x dash n cross 1, this equal to 0. This is the basic concept of standard representation of state variable method. Now we will see some questions related to it.